Welcome students on my channel. So once again this is Amit Burte from Mystery Valley Chemistry. So in today's video we'll discuss a very important rule. We'll find this rule in hydrocarbon and the rule is Markovnikov's rule. This Markovnikov's rule. It's a very important rule and this rule is actually find this rule in alkenes, one of the part of hydrocarbon. Okay, so what this rule says, whenever unsymmetrical, okay, we'll see that rule later on. Let me explain this rule with the help of example. CH2 then double bond CH2, it's alkene, right? Yes, it is a alkene and it is symmetrical alkene. It is symmetrical alkene because the substituents of these two carbon atoms are same, meaning it is symmetrical alkene. And we're going to add it HX. HX means halogen acid or hydrogen halide also, right? Now this HX is not symmetrical, it is unsymmetrical reagent because if we separate this HX molecule, then this will give us H and X, which are not same. So as it gives different parts or different fragments, so therefore this reagent is a unsymmetrical reagent. Okay, so this rule is applicable only when both are unsymmetrical. But here first of all I have taken a simple example of alkene which is symmetrical alkene. So as alkene is symmetrical, therefore addition of this reagent which is unsymmetrical, you can add this reagent by two ways. Means either you can add this H on this first carbon so that Cl goes to another carbon, or you can also add this H to this carbon so that Cl goes to first carbon. But in both cases we'll get same product, right? So let us check when we add this H on first carbon so that Cl goes on second carbon and double bond will convert into single bond. So we'll get CH3 then CH2 and this CH2 is now having Cl atom. Okay, so what is this? It is ethyl chloride. It's ethyl chloride or also called chloroethane. Ethyl chloride or chloroethane. Now if I add this H, instead of adding this H on this carbon, if I add this H over here, so that Cl goes on this carbon, then again I will get same product. I will get product like this Cl, then CH2, and then this carbon will become CH3. Now they are not different, they are same. It is also ethyl chloride or chloroethane, right? Yes, why will get same product? Because alkene is symmetrical. Okay, let us have one more example. Let's consider this CH3, then CH double bond, CH single bond, CH3. Now this alkene is also symmetrical alkene. It is called butene. It is called butene. And let us add HBr instead of HCl. I'm adding here HBr. Now your alkene is symmetrical because the substituents of these two carbon atoms are same, H and CH3, H and CH3, but reagent is unsymmetrical. Okay, in order to apply this rule called Markovnikov's rule, both must be unsymmetrical, right? So as symmetrical, alkene is symmetrical, so any kind of addition of this reagent gives us what? Same product like this. So let us add this H on this carbon and Br on this carbon. So this carbon CH becomes CH2, double bond converts into single bond, and this CH is now having Br atom. So you get CH3, then CH changes to CH2, then this CH is having bromine atom Br, and then here is a CH3. Now this alkyl halide, it is known as what? It is 2-bromobutane, correct? It is 2-bromobutane, or its common name is a secondary butyl or secondary butyl bromide. Secondary butyl bromide. Okay. So these two are the reactions in which unsymmetrical reagent is added on symmetrical alkene, where this rule is not applicable. Okay. Yes. Now let us have unsymmetrical alkene and unsymmetrical reagent. That is once again halogen acid or hydrogen halide. And see what happens. CH3, then CH, then double bond, CH2, and plus, let us have here HBr. HBr. Then actually reaction takes place in presence of CCl4. So here alkene is not symmetrical. Alkene is unsymmetrical and a reagent is also unsymmetrical. Okay. So when both are unsymmetrical, then reaction follows this rule known as Markovnikov's rule. It's the Markovnikov's rule. Now according to this rule, let us first of all break this HBr. Now, HBr on fragmentation uses what? H plus ion and Br minus ion. So these two are the fragments of this HBr, which are different. Therefore, this reagent is a unsymmetrical reagent. Now, this part is the negative part of this reagent, and this is the positive part of reagent. And what this rule says, whenever unsymmetrical alkene is there, and it is allowed to react with such type of reagent, that is unsymmetrical reagent, the negative part of the reagent gets attached to that carbon which carry less number of hydrogen atom. Okay, so it is the negative part of this reagent, and among these two carbon, which carbon is having less number of hydrogen? Yes, this middle carbon is having only one hydrogen, and this carbon is having two hydrogen atoms. So negative part of the reagent gets attached to that unsaturated carbon which carry less number of hydrogen atom, giving that as a main product, major product we can say. Second, another type of addition is also possible. Okay, this Br, it may get attached to what this CH2, so that this H goes toward this CH, making this CH as a CH2, and this will have Br atom, double bond will convert into single bond. But that product is found to be minor one. And according to this rule, Markovnikov's rule, the major product of the reaction is that where negative part gets attached to carbon carrying less number of hydrogen atoms. So that H goes to what? This carbon atom, double bond will convert into single bond, giving this as a main product CH3, then CH, then here this is a Br atom, and then followed by CH3. Okay. Now this linkage is the isopropyl linkage, or this is the isopropyl group. So we can write its name, common name, as isopropyl bromide. It's isopropyl or isopropyl bromide, whose IUPAC name is a 2-bromo-propane. It's a 2-bromo-propane. Right? So here this rule is applied. That is Markovnikov's rule. So according to this rule, or how we can write a statement for this rule? Yes, whenever unsymmetrical reagent, unsymmetrical, unsymmetrical reagent is added to unsymmetrical alkene, is added to unsymmetrical alkene, then what happens? Yes, then negative part, negative part of whom? Yes, reagent, negative part of reagent gets attached to gets attached to that unsaturated carbon, that unsaturated carbon which carries less number of hydrogen atoms. So it is a rule, it is a statement of this rule called Markovnikov's rule. Got it? Yes, when unsymmetrical reagent, that is like HBr, is added to unsymmetrical alkene like propene, then negative part of reagent, that is Br minus in this case, gets attached to that unsaturated carbon which carry less number of hydrogen atom. Okay. Now the carbon having less number of hydrogen is also known as more or highly substituted carbon. Highly substituted carbon also. Okay. So you can also state this rule like when unsymmetrical reagent is added to unsymmetrical alkene, the negative part of the reagent gets attached to that unsaturated carbon which is more substituted. Okay, or which is highly substituted. Now what is highly substituted carbon? the carbon having less number of hydrogen atom, we can call that carbon as a highly substituted carbon atom. So it is this rule known as Markovnikov's rule. Got it? Yes. Actually, along with this, second product is also possible, but the percentage of that product are found to be less. Means this isopropyl bromide is found to be major one. So यहाँ पे मैंने क्या लिखा है, जो मेजर प्रोडक्ट है ना वही लिखा है, माइनर प्रोडक्ट नहीं लिखा है. Got it? Yes. So let us have one more example. Let's consider here another unsymmetrical alkene. For example, this CH3, then CH2, then CH, double bond CH2. Right? Now what it is also unsymmetrical alkene because the substituents of these two carbon atoms are not same. Here this carbon carry 2H and this carry 1H and one ethyl group, meaning it is unsymmetrical alkene. And the name of this unsymmetrical alkene is correct. It is a but1ene. It is but1ene. And let us add here HCl, which is also unsymmetrical. So when both are unsymmetrical, then reaction follows this rule known as Markovnikov's rule. According to which negative part, which one is negative part? Yes, Cl minus. Negative part of the reaction gets attached to that unsaturated carbon which carry less number of hydrogen atoms, or correct, or which is a more or highly substituted carbon. So in this case, this Cl is going to add on this carbon atom, that is CH, making this CH as a CH with Cl, and H gets added on this carbon, converting this CH2 into what? CH3. At the same time, double bond converts into single bond. So we'll get this product CH3, then CH2, then CH with Cl, and that CH2 converts into CH3. So it is the secondary butyl chloride, correct? It's a 2-chlorobutane, that is secondary butyl chloride also. Followed. Similarly, suppose if I have this alkene, you find reaction like this one. It's a bond line formula for 2-methyl propene, and again it is unsymmetrical alkene. So let us add HBr. If I add HBr on it, or HCl, or even HI also, not HF, fluorinated compounds are found to be explosive in nature. So here this negative part of the reaction gets attached to carbon. Which carbon? Which unsaturated carbon? Carbon carrying less number of hydrogen atom. Now this carbon is not having any hydrogen atom. That's why we can call this carbon as a highly substituted carbon. And this negative part gets attached to that carbon, which is a highly substituted carbon, and H gets attached to what? This carbon. So this CH2 converts into CH3. So you get this product. Dash, it's a methyl branch. Here's that. Here is a CH3. It is also CH3. And here is what? Br. So you get T-butyl bromide. It is called tertiary butyl bromide, or 1, 2, 3. It's a long chain. This become branch, methyl branch present on second carbon. Second carbon also have Br atom. So it becomes 2-bromo, 2-methyl propane is the IUPAC name of this alkyl halide. Got it? So here also reaction follows same rule, that is Markovnikov's rule. That is negative part gets attached to carbon carrying less number of hydrogen atoms. So it's a about Markovnikov's rule. Followed? Yes. Now this Markovnikov's rule follows actually ionic mechanism. It follows ionic mechanism, and that anti-Markovnikov's rule, which I want to discuss now, it follows a different type of mechanism, that is radical mechanism. So this rule follows a radical mechanism. It's an anti-Markovnikov's rule. It clearly indicates that this addition of HX in this case is going to take place, yes, in opposite manner as that of what? Markovnikov's rule. Now this Markovnikov's rule, it was studied by the scientists Kirch, MS Kirch, and Mayo, FR Mayo. So that's why this rule is also known as Kirch-Mayo rule, or it is also called Kirch-Mayo effect. Effect. And as this rule, or as this effect is observed when peroxides are there, therefore this effect is also known as peroxide effect. It is also called peroxide effect. So anti-Markovnikov's rule, that is what peroxide effect, and that is as well what Kirch-Mayo effect. Okay. So let us have once again same alkene, that is a propene. So CH3, then CH, then double bond CH2. It's a propene plus HBr only. Remember, it is very notable bond HBr. This reaction is not, means anti-Markovnikov's rule is not shown by HCl, or HCl, addition of HCl will not follow this AMR, that is anti-Markovnikov's rule. Similarly, addition of HI also don't follow this AMR rule. Now why? Because the amount of energy, as I said earlier, that this anti-Markovnikov's rule follows radical mechanism. So the amount of energy needed to break this HBr bond, that is bond dissociation energy of this HBr molecule, is found to be 430 kilojoule per mole. Okay. Similarly, for HCl, it is found to be around 378 kilojoule per mole, and for next molecule is found to be 200 and something 47 kilojoule per mole for HI. Okay, so if we observe these bond and dissociation energies, then we can say that this HI should be highly reactive because of what? Lowest bond dissociation energy, and this should be less reactive. This should be what? Oh, sorry. For HCl it is 430. Extremely sorry. For HCl it is 430, and for HBr it is 378. So this should be less reactive. So it is less reactive towards this reaction. That's why it is not shown by this HCl. Means AMR. HCl will not follow this AMR, or it is not. You will not find this HCl as an unsymmetrical reagent in case of anti-Markovnikov rule. Then what is the problem with this HI? Though it is having least energy, why is it not shown by this HI? Because HI on dissociation, homolytic fission, because this mechanism, this rule follows a radical mechanism. So it undergo homolytic fission, giving rise to what? H dot and I dot. We get two radicals, hydrogen radical and iodine radical, and two such iodine radicals, they couples together, giving a stable molecule of what? Iodine. Meaning, iodine radical is not available for the reaction when we use this HI as an unsymmetrical reagent. So now what left? It is HBr. That's why AMR, that is anti-Markovnikov's rule, is shown by only HBr. So you find one question in MCQ, that is HBr, which among the following hydrogen halide shows or follows AMR rule? So it is only HBr, that is hydrogen bromide. Now this effect is observed only when there is a peroxide. There is a peroxide. Now peroxide, you can have any peroxide. Actually, peroxide means it's a peroxide. Peroxide. For example, the simple peroxide is this HOOH. That is the number what? H2O2. So it is hydrogen peroxide, right? If I replace this H by Na, I will get Na, then O, and then H. That is, I will get NaHO2. NaHO2. So it is called sodium hydroperoxide. And if I replace both H by Na, I will get Na, then O, and then Na. That is, I will get Na2O2. Na2O2. So it is also peroxide. It is called sodium peroxide. Similarly, we can also have this peroxide. C double bond O. Here is a dash on. Then C6H5. Now this group is known as, it is called benzoyl group. It is called benzoyl group. And here also same C double bond O, and then C6H5. So same group one more time. So it is called benzoyl peroxide. Okay, it is called benzoyl peroxide. So you can have any peroxide. So whenever peroxide is there on a row, then reaction always follow anti-Markovnikov's rule. So your reaction follows anti-Markovnikov's rule. So addition takes place opposite to that of what? Markovnikov's rule. Your anti means opposite. Opposite to what? This means what? Markovnikov's rule. So your negative part of the reagent gets attached to what? That carbon which carry more number of hydrogen atoms. Right? In Markovnikov's rule, negative part of the reagent gets attached to carbon carrying less number of hydrogen atom, that is highly substituted carbon. But in AMR, negative part gets attached to that carbon which carry more number of hydrogen atoms. That is what? Less substituted carbon. So here this Br gets attached to this CH2, and H gets, or it goes on this carbon, making this carbon as a CH2 and this as a CH2 with what? Br, giving that as a major product. Actually, again, that Markovnikov, like Markovnikov's rule, in this case also two products are possible, right? Means we can also add this Br on this carbon and H on this carbon, so we get isopropyl bromide, and when we add HBr like this, we will get N propyl bromide, and N propyl bromide is found to be major one. So that's why I'm writing only major product of this reaction, which follows this AMR, that is anti-Markovnikov's rule. Okay, so what is that? That is the N-propyl bromide, N-propyl bromide, or N-propyl bromide, or 1-bromopropane also. So it is the major one. Got it? So it is AMR. So how can state this rule? When unsymmetrical reagent, okay, in case of halogen acid it is only HBr. So when HBr, that is unsymmetrical reagent, is added on, or is added to unsymmetrical alkene, is added to unsymmetrical alkene, then in presence of, yes, in presence of peroxide, that is peroxide, any peroxide like hydrogen peroxide, sodium hydroperoxide, or benzoyl peroxide, then what happens? Reaction addition takes place according to this AMR. Then what happens? Negative part of reagent gets attached to that that unsaturated that unsaturated carbon, which carry which carry or which carries more number of hydrogen atoms, which carry more number of hydrogen atoms. That is what? Which is a less substituted carbon atom. So it is statement of anti-Markovnikov's rule. That is when unsymmetrical reagent, in case of HX, it is HBr. That is when HBr is added to unsymmetrical alkene like propene in presence of any peroxide, the negative part of reagent, that is Br minus, gets attached to that unsaturated carbon, which carry more number of hydrogen atom, giving that as a major product. So that's why the major product of this reaction, because of presence of peroxide, is N-propyl bromide. And in absence of peroxide, reaction will follow Markovnikov's rule, where we'll get isopropyl bromide as a major one. Okay, that is 2-bromopropane. Hope you got this rule. Yes. So let's have one more example so that you can get clear idea. Let us have here but1, which is also unsymmetrical alkene. CH3, then CH2, then CH, double bond CH2, plus once again same, it is HBr only, not HCl or not HI, in presence of peroxide. Then reaction will follow anti-Markovnikov's rule, and what this rule says, negative part of reagent gets attached to that unsaturated carbon, which carry more number of hydrogen atoms, so that H goes to another unsaturated carbon, double bond will convert into single bond. So get CH3, CH2, this CH changes to CH2, double bond into single bond, CH2 with what? Br. So we get CH3, then CH2, then CH2, then CH2, and then Br. Now this compound is known as N-butyl or N-butyl bromide, whose IUPAC name is 1-bromobutane. Got it? That is 1-bromobutane. Now what about notable point of this particular rule? Yes, this rule, it is a addition of HX with this AMR, it is shown by only HBr, means only HBr undergo this AMR addition amongst different halogen acid. And second notable point is that it follows radical mechanism. And that previous rule, that is Markovnikov's rule, it follows, yes, it follows ionic mechanism. Follow? So it's about Markovnikov's and anti-Markovnikov's rule. So if you want mechanism, then we'll discuss that mechanism in next video. Okay. So अगर आपको वीडियो अच्छा लगता है तो प्लीज लाइक इट, सब्सक्राइब इट, एंड शेयर विद योर फ्रेंड्स. थैंक यू.